Toggling switches to show numbers is cool, but what if we could make the circuit think for itself? Instead of using a tape to measure distance, how about we design a digital meter that measures the distance of an object and displays it directly on a 7-segment display? Kind of like reading a serial monitor, but visually. But before we get into that, let's step back and understand how a 7-segment display actually forms its numbers. For example, how does it know how to show the number 2 or 3? We see 7-segment displays everywhere in clocks, calculators, and other digital devices. But how are those numbers really formed? A 7-segment display is made up of 8 LEDs. 7 of them are used for segments labeled A to G, and 1 more is for the decimal point. Now, these displays comes in 2 main types. Common cathode, where all the cathodes are tied together and connected to ground. Common anode, where all the anodes are tied together and share a positive pin. That's why part numbers matters. Not all 7-segment displays are wired the same way. In this build, we are going to use a common cathode display because the driver IC we are working with is designed for that type. To display the digit 1, we need to turn on segments B and C. To display the digit 7, we need to turn on A, B, and C. So, how does the circuit know which segment to light up for each number? That's where the BCD decoder IC comes in. BCD stands for binary coded decimal. It's a way of representing decimal numbers 0 to 9 using just 4 bits of binary. For example, the number 5 in BCD is 0101. The number 2 is 0010. But to make this useful for display, we need a chip that takes those 4 binary inputs and translates them into the correct 7-segment output. That's where the CD4511 BCD to 7-segment decoder comes in. Here is how it works. It takes 4 bits binary input on pins 1, 2, 6, and 7. It converts that into 7 outputs, pins 9 to 15. That drive the 7-segment LED. Pin 16 is VCC and pin 8 is ground. The IC works with a supply range of 3 to 15 volts. A few extra pins make it more flexible. Pin 3 is the lamp test. If pulled low, all segments light up for testing. Normally we keep it high. Pin 4, the blanking input. If low, it turns off all segments. Pin 5, it's the latch enable. This stores the current data if you set it high. The display holds its value even if the input changes. For our setup, I am using a DIP switch. Even though it has 8 switches, I am only using 4 of its pins to send binary input to the IC. To avoid floating inputs, the unused pins are tied to ground. The output from the ICs are wired to the segment of the display. And now we can actually form digits. So let's test our build. When I close switch 4, that makes the input 0001, while the other switches stay at 0. The decoder reads that binary number and outputs the decimal value 1 on the display. Now if we reset that and close switch 3, the input becomes 0010, which gives us a decimal 2. If I close switch 3 and switch 4 together, the input is 0011 and the decoder outputs 3. We can keep going like this, following the truth table to get numbers from 0 to 9. But flipping switches every time isn't much fun, right? So let's upgrade the project by using a sensor. Instead of switches, we will using an ultrasonic sensor that measures distance, and we will display that distance directly on the 7-segment display. To do that, we need a microcontroller. I will be using an ESP32, and I have already written the simple code in the Arduino IDE. The code groups binary coded decimals from 0 to 9, and it does an increment automatically when a new distance is measured. Here is how it works. For example, if the ultrasonic sensor detects a distance of 1 cm, the microcontroller represents that number in binary using the BCD condition in the code. The decoder then takes that binary input, converts it into decimal, and finally displays the result on the 7-segment display. So instead of manually flipping switches, our project measures distance in real time and shows the result. Much cooler and more interactive. and accurately. So I took a measuring tape to take the distance from the sensor to the block, and it was exactly the same even if I moved the block and taking the reading of its new position, and it was just as the same with the tape. I want you to understand that this project is just for fun and just to have some understanding of how some digital display use binary numbers and convert them to digits, which can be used as distance reading. And we choose to read up to 100 meters. You will need 3 of these ICs and 3 of this display. Well, that's all for this video. Make sure to subscribe, like, comment and share this video with your friends so they can also learn something new. Thank you.